Are you from the industrial world and curious about machine learning applications? This might be a showcase to further awake your interest in the subject. We will walk through my last project on Kaggle. It's about a meta-analysis of machine learning competition dynamics. The main question to answer through this project is how Kaggle competition workflows contribute to real-world deployment of predictive maintenance systems in the energy sector. I will start with a brief introduction about the data source, followed by the notebook presentation of Kaggle, and finally, I will show and present the conclusions. I hope you enjoyed this delivery, and don't forget to add your thoughts in the comment section below. Here, we will dive into data about Kaggle, and I will share with you the best meta-analysis to investigate how Kaggle competitions and community activity measured through meta-Kaggle dataset impact the advancement of machine learning practices and adoption in industry. Kaggle has 15 years of history and is a well-known digital place where machine learning knowledge evolves through competitions and community collaborations. The meta-Kaggle dataset stores public data on competition and submissions. You can find data like competition tag, forum message, and many more. Meanwhile, the meta-Kaggle code dataset stores and explores notebook content. Walk through well-organized directories to find and discover valuable kernels. If you are curious about the main motivation behind this project, you can read my dedicated article with this link. This report can be considered as a practical example of informed decision-making workflow. Generally speaking, I will stage the workflow into 4 main steps. First step is the exploration of user activities, competitions, and notebooks related dataset from 2010 to 2025. For example, you can explore the statistics of total teams per competitions and see how submission behavior evolved during that period of time. The second step is a funnel that requires the usage of keywords to search competitions of interest. The filtering goes from wider terms and general purpose to reduce the subset of competition. Additionally, a topic analysis was performed to contrast and improve the keywords used. For example, the general terms for predictive maintenance returns competition that span around 3,000, while specific terms for predictive maintenance in the energy sector cover around 500 competitions, with a reduction factor of 6. These subsets were used to study the host and the evaluation metric in different categories. A relevant point to highlight from this analysis is that community-hosted competitions are very important for general-purpose machine learning models, while featured-hosted competitions play a key role in the specialization of machine learning models and the adoption of specific metrics. This highlight will lead to the third step, which is the selection of a competition based on metrics such as total competitors, total submissions, and number of score submissions. A competition stands out among the group of maintenance and energy sector related contests. As you can see here, the title words indicate industrial activity and dedicated machinery, power line fault detection, flare prediction, wind speed at wind turbine, and so on. Power line fault detection, held in 2018, was identified as a successful competition to further explore the community-driven development and team dynamics. Finally, the fourth step, the forum and kernels related dataset were combined to produce a competition-enriched subset, which can be found here. Due to time available and consistency constraints throughout the project, the main focus was on team collaboration during the competition, meaning from December 2018 to March 2019, which is roughly estimated around 11% of all the data available. If you want to learn and explore the kernels produced by the team, the most important thing is the list of the most voted kernels and how to find them quickly in Kaggle code, as presented below. Another point of impact is the leaderboard, where you can see the public and private score trajectory of the top 10 teams. And finally, the forum itself can be considered as a masterclass in coding and signal processing. I'm sure there is much more to discover about this project, but for the sake of convenience and time, I will stop here and move on to the conclusion. The takeaway from this project is a simple, well-structured data science workflow to filter and analyze competition data from the Kaggle and Kaggle code dataset. This approach lays the ground for identifying relevant data sources, combining datasets to measure impact and support informed decision-making. Through this framework, we explore the evolution of various aspects of Kaggle competitions from 2010 to 2025. This historical perspective offers valuable insight into the platform's dynamic and how they reflect broader trends in the machine learning ecosystem. While the primary focus of this work is on industrial applications, the methods and tools provided in the notebook are versatile and can be adapted to investigate virtually any topic of interest on Kaggle. As a case study, we identified competition, powerline fault detection using a custom keyword matching dictionary, and this use case highlights the following points: Kaggle role in real-world machine learning problem solving, the educational power of open collaborative platforms, and finally, how community-driven engagement through upvote discussion and information mirror real-world machine learning project practices. It's important to note that this project tapped into only about 11% of the knowledge created around that unique competition, which took place 6 years ago, meaning that 89% of community-vetted knowledge remains unexplored and is a compelling opportunity for further research and discovery. If you found this mini project helpful or inspiring, I encourage you to dive deeper into Kaggle, explore new competitions, or share your reflection in the comments.